Welcome to the Crazy Hat Chemist. So another video today in bonding, so let's get moving here. Bam! Today we're going to determine the molecular geometry number 13, lucky number 13, just for you. It's my favorite number. So we're going to determine the molecular geometry or shape of a xenon tetrafluoride. So two nonmetals together, that's a xenon and a fluorine, and tetrafluorines, that's 4 fluorines, so you should get this formula XeF4. So the first thing that we're going to do before we can get the shape is that we need to draw the Lewis dot structure. So I'm going to refer you back to a previous video, and you're going to review that video, and that's drawing Lewis dot structures number 13. And you should see in your lower left-hand corner the Lewis dot structure for xenon tetrafluoride. Okay, so we are following this axe-like structure here, which we've gone over multiple times now, 13 of them now today, at least in this series. Okay, and then we're going to figure out what is the central element. The central element is the xenon, that is the A. There's always one single A. How many bonding domains, how many things that are attached to that xenon? There are 4, so that's X4. Okay, and then how many lone pairs are around the central element? The central element only. I see 2 sets of lone pairs around the central element. That's E2. So you should have AX4, E2. That corresponds to 4 bonding and 2 non-bonding domains. Now again, I think I've mentioned this multiple times. I'll mention it again. You have to memorize the shape that's associated with the axe formula, or you have to memorize the shape associated with the bonding or non-bonding domains. Either one. I'm going to show you a picture or a model of this shape before I unveil the shape yet one more time here. And then hopefully you can get the shape. So the lone pairs of electrons are what I am holding onto right now. Okay, and then you should see that within the plane, there's 4 atoms within the plane. Within the plane, there are 4 atoms. Those are the fluorines. The central element there, the yellow central element, is the xenon, and I'm holding on the 2 sets of lone pairs. Now, those lone pairs must be opposite of each other because this is an octahedral structure, and they must be as far distant away from each other as possible. That's following the Vesper shape, and that means that they need to be 180 degrees away from each other. Okay, and that would yield us with this structure, which is a planar structure, which is a 4-membered planar structure, and of course that would be square. Hopefully you see the square, or the square planar structure. Okay, so square planar structure. Hopefully that works out well for you. I'll spin that around just a little bit more so that you can actually truly see that very well. Okay, and make sure that you see that these atoms here are within the same plane. That is the xenon and the 4 fluorines, and the lone pairs of electrons are at the poles. Okay, I hope you enjoyed that video, and yet another hat from Peru. Give me a thumbs up if you like that video, subscribe to my YouTube channel, and I will see you for more cool chemistry videos next time. Bam, baby!